Welcome to Rationality, Reason, and Reality. I'm Supernova. Today I'm going to go over logic, how it works, both deductive logic and inductive logic, and I'm going to give you examples of both. This is just going to be a very brief overview, and I'm planning to make another video in the near future about some of the more advanced forms of deductive logic. But let's start with the very basic. If you look it up on Wikipedia or some site talking about logic, it will almost certainly say that it is made up of premises that inevitably lead to a conclusion. And that's not very helpful because how? How do we know that premises inevitably lead to a conclusion? Sometimes it's intuitive. We're born with a sense of logic. But I want to go a little deeper and give you a way that you can actually say, yes, this is definitely a logical format. Let's look at the classical example. This is the one that almost everybody learns when they first learn logic. Aristotle was the father of logic. He's the one who first came up with these systems, and that's why the classic argument mentions Socrates. It says, premise 1, all men are mortal. Premise 2, Socrates is a man. Conclusion, Socrates is mortal. Now you'll see I gave all these little abbreviations with letters just so I could show you this little, I guess you could call it a Venn diagram that I made, where we have a group of mortals, M, things that are mortals, however you want to look at it, P, people, or men. I think that's what they meant when they called Socrates a man. The group of people is within mortals because all people are mortals. Therefore, the entire group of people is within mortals. And we have a little dot there that shows S. That's one example of a person, so it's in the group of people. And therefore, it is also a mortal because by being in the group of people, which is inside of the group of mortals, it is inside the group of mortals. So therefore, we know that Socrates is a mortal. I gave another example down here, a little more up to date, I guess, something we can relate to. Premise 1, all cats are lizards. Premise 2, Boots is a cat. Conclusion, therefore, Boots is a lizard. And you can see down here we've got all lizards as a group, L, and we've got cats, C, within the group of lizards, and B for Boots. There's Boots inside the group of cats, therefore, Boots is a lizard. Now you may be saying to yourself, no, cats aren't lizards. Well, that's true. That's why I offer this example as well. Because logic doesn't necessarily lead you to truth. It does if it's used correctly. But just the logical format alone won't do it. The premises also have to be true. When we have either of these forms here, it's called a valid logical argument because the format is correct. As you can see with the diagrams here, they definitely lead to something correct if the premises are true. So they're both valid. Now, because we know that all men are mortal, or at least we highly suspect it, we haven't come across any counterexamples, we know that this is not only valid, but true. Therefore, it's called sound. It's a sound logical argument. If the format is valid and the premises are true, the conclusion has to be true. That's how logic works. So these premises are true, therefore Socrates is immortal. We know that to be true. Now here we know that all cats aren't lizards. They aren't by definition. Therefore this premise is false, which makes the conclusion also false. It's valid but not sound. And so when you're looking at an argument, you not only have to make sure that the logic is valid, but you also have to make sure that the premises are true. Now, we're going to look at a basic inductive argument. This is, again, the classical example. The sun rose yesterday, premise 1. Premise 2, the sun rose today. Conclusion, the sun will rise tomorrow. Now, unlike deductive arguments, this isn't necessarily true. And this classic example is such a great example because what we know of the sun, it leads us to believe that the sun is someday not going to exist. It will cease to exist. It will go nova, or it will just die. And Therefore, it won't always be true. We can't always conclude the sun will rise tomorrow, but we highly suspect it will, because not only do we have these premises, but we could add many, many more. The sun rose the day before yesterday, and the sun rose the day before that, and the sun rose every day in our past as far as we know. And because there are so many premises to support the conclusion, we call this a strong argument. Inductive logic isn't looked at as sound or valid. I guess it's always valid. I don't know what an invalid inductive argument would look like. But it's considered weak or strong depending on the number of premises you have, depending on the number of examples. And because we have so many and we have no counterexamples, it's a very strong argument. And you'll find that that's true. The sun probably will rise tomorrow, and it will probably rise the day after that and the day after that, because this pattern is so well established. We know that it's very likely to come true. And here's just an overview of the terms we've talked about. Valid just means it's got the proper logical format, as I've shown you with both. Sound is not only valid, but the premises are true. A sound argument is true. Weak means that there's little inductive support, very few premises here in the inductive argument. And a strong argument means there's great inductive support. There are many, many examples to back it up. And also, when we're looking at an inductive argument, we want to find that there are no counterexamples, because that would obviously break it. And if we have more counterexamples than examples, then it's false, I guess I could say. So I also said that I would go over some more examples. Because I'm an atheist, I like to look at Christian arguments when I talk about logic. And so, as far as Christian arguments that use deductive logic, any of you that are familiar with it, you're probably well aware of the Coulomb cosmological argument that William Lane Craig makes is definitely good, valid, deductive logic. I'm quoting from memory here. I don't use a script with these, so I hope I get this right. Premise 1, everything that begins to exist has a cause. Premise 2, the universe began to exist. Conclusion, therefore the universe had a cause. Now he's arguing this cause is God, but he doesn't actually go on to say as much. I guess maybe he would define God as the cause of the universe, though I would take exception with that, because if you believe that the Big Bang caused the universe to exist, would that make the Big Bang God? No, that's probably the main reason why he throws that off the end. But it's valid. It's got a proper format. It's just like those examples that I showed you. Everything that begins to exist has a cause. So within the group of everything that is caused, everything that begins to exist would be within that. And then the universe began to exist. The universe is an example of something that began to exist. Therefore, it has a cause. If the premises are true, then we would have to be led to believe that. But we're not sure that the premises are true. I wouldn't go so far as to call it unsound, but it's unknown. When he says that everything that begins to exist has a cause, we don't know of any examples that would fall into that, except the universe, and we don't know if that's true. Nobody was around to observe whether it had a cause. Now, he has written a book in which he expanded on these ideas, and of course he gave examples, such as says you began to exist. But many people pointed out that we didn't begin to exist from nothing. We're a rearrangement of pre-existing materials. Your mother had to consume food which had parts in it that made you. You know, life doesn't just grow out of nothing. We have to be made out of pre-existing parts, and that's why we consume food, so that we can keep replacing parts that leave, and so we can grow. And so that's not an example. We don't have any examples of something that began to exist in the sense that the universe began to exist. So we don't know whether that premise is true, and so we don't really know if the argument is true. It's not really sound, it's just unknown. And so in this case, we ought to rely on skepticism, which prevents us from getting conned into things that we'd be credulous about. As far as inductive arguments go, I'm not going to go with a Christian argument here, because frankly I don't know any Christian arguments that are made inductively. I would rather use one of my own that I've argued about on the internet many times. If you've looked through my catalog of videos, you might notice that I have some about math because I disagree with the consensus of mathematicians that believe 0.9 repeating equals 1. I've shown that in many ways, and my argument is based on inductive logic. For instance, 1 minus 0.9 equals 0.1. Premise 2. 1 minus 0.99 equals 0.01. Premise 3, 1 minus 0.99 equals 0.001. Conclusion, if you subtract a series of 9s after a decimal point from 1, you will get a decimal point followed by a number of zeros equal to the number of 9s minus 1, followed by a 1. Now, we know that this is true for any series of finite 9s. It doesn't matter how many 9s follow a decimal point. If you subtract that from 1, you will get a series of zeros after a decimal point followed by a 1 equal to that exact length. And so when we talk about an infinite series of 0.9 repeating, I say, well, this follows the same pattern. This inductive logic ought to still be true about that. We would have an infinite number of zeros that is one shorter than the infinite series of 9s, followed by a 1. And they would say, no, it's just 0. They're not coming up with that from inductive logic. They believe that it's an exception to the rule. It might be a case of special pleading, but not necessarily. We'll go over that when we discuss the logical fallacy of special pleading. But anyway, my argument would be based on inductive logic. So I think it's at least worth consideration, or more than it gets anyway. So I hope that you appreciated this video. Please comment on it. Tell me what I could have done better, or what I did well. And I will come out with another video on logic soon. But I would like to skip ahead to the fallacies because they're a lot more fun, especially when we're taking apart arguments that we don't agree with. So I'll see you next time. Bye.